Assalamualaikum. My name is NASYIRAH 291576. I'm gonna presenting about introduction, history, evolution, and the last one is various field in angular kinematic. Introduction about angular kinematic that studies the spinning of motion object. Also, the angular kinematic, we know that three key concepts. They have angular displacement, angular velocity, and last one in angular acceleration. We know that angular displacement, that how much object rotates in radian or degrees. Angular velocity, how much fast an object rotate. And last one is angular acceleration, how quickly an object rotate, that speed up or slow down in radian per second square. So that this concept of angular kinematic really crucial in various fields like engineering, for example, gear, turbines, robotic joint movement, astronomy, planetary motion, sport athlete movement, and so on. Also, the understanding rotational behavior, angular kinematic help us to analyze physical event and to create advanced technology and industry. For history and background of angular kinematic, the studies of angular kinematic we begin in ancient time with Aristotle. Aristotle is the one who explored the nature of motion. Archimedes also later investigated the levels and rotational equilibriums. During the Renaissance, Galileo Galilei advanced the understanding of motion, or we call angular kinematics, with his experiment, with his various experiments. In the late of 17th century, Isaac Newton's law of motion laid the foundation for explaining rotational dynamics, where Isaac Newton he created the first and the second law of motion. Leonhard Euler further also developed this idea in 18th century with mathematical equation for rotating bodies. Also, this historical, you can see that it can contribute, have shaped our current understanding of angular kinematic until now. For the evolution of angular kinematic, as we can see, for the first beginning Asian is Aristotle, and the last future is 20th century advance. First is Aristotle from 384 until 322 BCE, where the first explore motion, that including rotation. Second, Archimedes from 287 until 212 BCE, where the study levels and rotational balance. Third is Galileo Galilei, 1564 until 1642 years, where he investigated motion in inclined planes and pendulum, that enhancing understand of rotation and acceleration. Fourth is Isaac Newton, 1642 until 1727, where Isaac Newton defined law of motion and applied them to rotation, also create the fundamental equation for angular kinematic. 5 is Leonhard Euler, 1707 until 1783, where he developed the mathematical description for rotate bodies and solidify rotational dynamics. For the last one is 20th century advance. There's many, which is quantum mechanics, relativity, and the last one is computational mechanics. Quantum mechanics is introduced the concept of spin at the atomic level. Relativity, where they provide insight into a rotational motion at high speed and in strong gravity. Last one is computational mechanics, where they enable a detailed simulation of complex rotational system. Angular kinematic also has in various fields, such as engineering, physics, biology, medicine, computer graphic, and animation. For engineering, the development and evaluation of rotating equipment, robotics, and aeronautical system. For physics, the investigation of rotating motion in element, atoms and celestial bodies. For biology and medicine, they explore the physical basic of animal and human movement. And the last one is computer graphic and animation, where creating a realistic rotating motion in virtual world.
Assalamualaikum. Good days everyone. My name is BINTI Zulkipli. My matrix number is 291646. So I'm going to present about three types of angular. So we start with angular displacement, represented by the Greek letter theta, measure the angle through which objects rotates about particular axis. Unlike linear displacement, which measure the shortest distance between 2 points, angular displacement focus on the charge in the rotational position of an object. It's typically measured in radian, degrees, or revolution. One full revolution corresponds to 360 degrees or 2 pi radians. As we can see, this diagram illustrates how angular displacement works. If the object rotates from point A to point B, the angle formed is the angular displacement. Next, we have angular velocity, denoted by Greek letter W or omega. Angular velocity describes the rate of which an object changes its regular displacement. It provides information on how fast an object is rotating and the direction of rotation. The standard unit of angular velocity is radian per second, but it can also be measured in degree or per second or revolution per minute. Lastly, we have angular acceleration, represented by the Greek letter A or alpha. Angular acceleration measures how quickly the angular velocity of an object changes over time. It indicates whether an object is speeding up, slowing down, or maintaining a constant rotational speed. The unit of angular acceleration is radian per second squared. This image shows an example of angular acceleration. As the slope of angular velocity time graph increase, it indicates positive angular acceleration, meaning the object is speeding up. Conversely, a negative slope indicates the object is slowing down.
Hello everyone, my name is DAULAY dari RABBANI 291127. I will tell you about the experiment that I have made in few days ago. In this experiment, I will calculate the displacement, the angular displacement, angular velocity, and angular acceleration of a pencil attached to the end of the ceiling fan. So before we start the experiment, we need the experiment setup to just obtain a ceiling fan with no palm string. Then attach a pencil to the end of the fan. Then turn on the fan at a specific level, and we need to use a stopwatch to measure the time it takes for the fan to complete the specific revolution. The formula of angular displacement is 2p times n. It means the number of revolution. So it means the angular displacement is 2p times 20 equal to 40p radians. And to calculate the angular velocity, the formula is angular displacement divided to times. It means that the angular velocity of the pencil is 40p divided to 10 equal to 4p radians per second. To calculate acceleration, I have a little bit different condition because acceleration needs change of velocity. So I turn off the fan, and the fan is completely stopped in 2 minutes 30 seconds. So the initial angular velocity is 4p radians per second, and the final angular velocity is 0 radian per second. The initial time is 10 seconds, and the final time is 10 plus 150 equal to 160 seconds. So the formula of angular acceleration is the final angular velocity minus initial angular velocity divided by initial time minus final time equal to 0 minus 4p divided by 160 minus 10. So the angular acceleration of this condition is equal to minus 0.025p radian per second square. It means the acceleration is the speed is decreased.
So we move to advantages for angular. For engineering, angular kinematic allow for precise calculation and design of mechanical system, ensuring accurate functionality. Also improve stability of structure and machinery through optimized design, and maximizing efficiency in rotating machinery by applying principle of angular motion. So for physics field, it's fundamental for comprehending the principle governing rotational movement, also essential in studying planetary motion, particle physics, and other natural phenomena. So for biology and medicine, it helps in analyzing and understanding the movement of biological organisms, also crucial in designing advanced medical devices such as prosthetics and robotic surgical tools. And lastly, for computer graphics and animation, it facilitates the creation of realistic visual effects by stimulating accurate motion dynamics, also provide realistic movement and character animation, enhancing the overall quality of digital content. So next, we're going to disadvantages of angular. For engineering field, angular kinematic requires advanced skill and tool for precise calculation, which can be challenging for engineers. Also reliant on idealized assumptions that may not always hold in real-world application, leading to potential inaccuracy. And on physics field, the mathematical formulas involved in angular kinematics are often intricate and difficult to solve. Also require precise measurement and high computational resources, which can be difficult to achieve and costly. For biology and medicine, it can accurately modeling biological system is challenging due to their complexity and variability. Also requires integrating with complex biological data, which can be difficult to obtain and analyze. And lastly, for computer graphics and animation, the creation of realistic visual effects and animation requires sophisticated algorithm and hardware. Also, real-time application demands significant computational power, which can be resource-intensive and expensive.